This isn't just a story of battery innovation. This is a moment where the timeline of progress splits from the limitations of the past. For many decades, lithium reigned as the silent power behind our everyday lives. It ran our phones, fueled electric cars, and even stabilized energy in our homes. But beneath that dominance, the cracks began to show. Soaring costs made energy storage a luxury. The constant fear of fire risks and thermal runaway loomed over EV manufacturers. Lithium supply chains tightened, dominated by only a few nations, adding political fragility to technological progress. Then quietly, from Tesla's most secretive laboratory, something groundbreaking began to emerge. A battery born not from rare elements, but from the most abundant metal in the Earth's crust. One that didn't require complicated materials or dangerous chemistry. It was not just a competitor to lithium, it was a complete dismantler of it. Tesla's aluminum-ion battery represents more than just a new material. It symbolizes a fundamental shift in how energy is stored, delivered, and perceived. Aluminum ions carry 3 positive charges per atom, while lithium carries just 1. That seemingly simple difference means 3 times more energy can be transferred with every ion. With this change, energy density soars without complex engineering or exotic substances. The implications are massive and immediate. The dangers that come with lithium, most notably, the formation of dendrites that pierce separators and cause fires, do not exist in aluminum-ion batteries. These new batteries are stable across a broader temperature range, from 40 degrees to 85 degrees Celsius. They are inherently resistant to overheating and eliminate the need for expensive cooling systems. What was once a major engineering hurdle has now become irrelevant. Lithium is not just problematic in performance. Its supply chain is fragile, controlled mostly by a small number of nations with limited reserves. The mining of lithium comes with devastating environmental and ethical consequences, particularly due to the use of cobalt. Aluminum, by contrast, is everywhere. It is the most abundant metal in the planet's crust and can be refined almost anywhere in the world. This makes the aluminum-ion battery not just a superior option in performance, but also a geopolitical and environmental win. The performance differences are staggering. While lithium batteries reach their limit at around 250 watt-hours per kilogram, Tesla's aluminum-ion batteries are achieving over 5,000 watt-hours per kilogram. This isn't a marginal improvement. This is a complete paradigm shift. A Tesla vehicle that previously offered 330 miles of range could now offer over 3,000 miles on a single charge. Battery lifespan, once a concern for consumers facing replacement costs in 5 to 10 years, has now entered a new territory. Lithium batteries typically last for about 2,000 charge cycles. Aluminum-ion batteries have shown the ability to endure over 50,000 cycles. That's equivalent to more than 70 years of usage. These batteries even have a self-healing mechanism. When tiny cracks appear in the electrodes, cracks that usually signal the beginning of battery degradation, the aluminum cells repair themselves. This preserves structural integrity and allows for decades of reliable use. Charging time is another realm where aluminum-ion leaves lithium behind. While lithium batteries can take up to an hour to reach 80% capacity, aluminum-ion reaches 100% in just 10 minutes. The reason is simple physics. Aluminum ions are smaller, lighter, and move 3 times faster than lithium ions. They don't generate nearly as much heat during movement, making fast charging not just possible but standard. Safety, perhaps the most public concern about lithium batteries, is where aluminum-ion changes the narrative. Aluminum-ion batteries are non-toxic and chemically stable. They cannot explode or catch fire under normal conditions. There are no thermal runaway risks. The chemistry is robust and predictable. Thousands of EV fires caused by lithium batteries will become a thing of the past. What used to be a risky gamble is now a secure promise. But aluminum-ion technology goes even further. It unlocks features that seem lifted from science fiction. Its self-healing electrode system isn't just a gimmick. In lab tests, electrodes damaged and repaired themselves within seconds. The result was a 99.7% restoration of the battery's original structure. In some cases, the new pathways formed by these repairs actually made the battery perform better than it did originally. Imagine a battery that not only heals itself, but improves over time. Then consider power capacity. An aluminum-ion Tesla battery can store up to 2,000 kilowatt hours. That's enough to power entire work sites or multiple homes for days. The car becomes a mobile power plant, not just a means of transportation. Tesla's survival mode system takes this further. During blackouts or emergencies, the system distributes energy intelligently. Essential devices are powered for weeks without any additional input. And what about shelf life? Lithium batteries degrade slowly, even when unused. Aluminum-ion batteries enter a crystalline state of deep sleep. They lose virtually no charge even after a decade of inactivity. When reactivated, they return to full functionality within seconds. These are not just upgrades. They are redefinitions. They introduce entirely new capabilities into the realm of energy storage. This is why the aluminum-ion battery doesn't just beat lithium. It renders it obsolete. What about cost? Affordability has always been a barrier to mass EV adoption. Lithium batteries are costly to produce and expensive to replace. But aluminum, the third most abundant element on Earth, changes that equation. A battery pack that once cost $7,500 can now be produced for just $2,000 to $4,000. That's a potential 20% drop in the total cost of an electric vehicle. And it gets even better. Aluminum-ion batteries maintain up to 95% of their efficiency even after multiple recycling processes. Lithium batteries degrade with each recycle, adding to long-term waste and cost. Tesla's upcoming Model 2 is a strategic masterpiece built on this premise. Priced below $16,000, it will outperform every car in its category. Over 400 miles of range, full recharge under 15 minutes, and battery life exceeding 70 years. It won't just be affordable, it will be liberating. A true lifetime vehicle that never needs a battery replacement. That doesn't burn, that doesn't degrade. 2025 is more than just a launch date. It is the moment a silent revolution begins. Elon Musk once said things would go ballistic. That time is now. Tesla has spent nearly a decade developing this technology in secrecy, and now it's quietly entering production. Insider reports confirm that full commercial deployment is just around the corner. Tesla's Battery Day 2025 could be the biggest technological announcement in years. This is no longer theory. This is reality. All the stars have aligned. Lithium supply chains are under stress. Prices are volatile. Governments are clamping down on extraction practices. And consumers are losing patience with EVs that promise more than they deliver. The moment for aluminum-ion could not be more perfect. If Tesla reveals a fully functional, mass-producible aluminum battery this September, then 2026 will mark the true mass adoption of electric vehicles. Not because of tax credits or green initiatives, but because the technology finally makes complete sense. This is the energy revolution, and it's not arriving slowly. It is slamming the door on the past and kicking open a new future. This is only half the story. The story of the aluminum-ion battery doesn't end with personal transportation. It begins reshaping the infrastructure of the entire world. With its incredible lifespan, safety, and charging speed, this battery becomes the cornerstone of a new energy economy. The grid as we know it begins to dissolve. Centralized energy distribution is replaced by localized, self-sufficient systems. A home powered by an aluminum-ion battery becomes independent of outages, peak hour charges, and aging transmission lines. Off-grid living becomes not just possible, but practical and permanent. Villages that once relied on diesel generators now power themselves with a single mobile aluminum battery station. In places plagued by disasters, like hurricanes or earthquakes, rapid response units with aluminum batteries restore power instantly. In areas too remote for traditional infrastructure, entire communities spring to life on battery power alone. What once required massive government-funded grids now fits in the trunk of a car. And in urban centers, the same battery technology redefines daily living. Electric buses recharge between stops. Garbage trucks never refuel again. Delivery vans operate silently and safely, saving cities from noise and pollution. Apartment buildings share communal battery arrays, reducing energy bills by 80%. Factories no longer shut down during blackouts. Construction sites operate heavy machinery with silent, emission-free power tools. From household appliances to emergency response, aluminum-ion powers it all. Even air travel is on the edge of transformation. Short-range aircraft that once burned jet fuel now use batteries capable of multiple takeoffs and landings in a single charge. With no risk of overheating and incredible energy density, aluminum-ion becomes the key to electric aviation. Tesla isn't the only player to see this future, but it is the first to act. While legacy automakers bet their futures on lithium's final chapters, Tesla is writing a new book. The battery supply chains they built over the last 15 years are suddenly irrelevant. Billions of dollars in lithium infrastructure begin to erode in value. Investors, once excited about lithium extraction, begin asking harder questions. Governments reevaluate subsidy strategies, and smaller EV startups pivot overnight or perish. The disruption spreads like wildfire. What starts with a better car ends with a rewritten world. Entire nations that were dependent on lithium-rich trade routes now look inward. Africa, with its massive aluminum reserves, steps into the spotlight. Countries that were once on the margins of the battery economy now lead it. Local mining becomes cleaner. Refining becomes safer. The environmental impact of battery manufacturing plummets. The aluminum batteries design, free of cobalt and nickel, means less human exploitation and fewer toxic outputs. Recycling centers grow not out of necessity, but opportunity. Used aluminum batteries are nearly 100% recyclable and retain most of their capacity. The entire life cycle of energy storage is now sustainable. Carbon neutrality becomes less of a dream and more of a design principle. Even in personal electronics, change comes fast. Smartphones that last a week on a single charge. Laptops that recharge in 5 minutes. Wearables that don't need nightly charging. Remote sensors that run for decades without maintenance. Medical devices that operate without fail in the most rugged conditions. Aluminum-ion isn't just the end of lithium. It's the dawn of seamless, invisible energy integration. Power becomes so stable, so fast, so abundant, it fades into the background. It's no longer something you manage. It's something you simply have. This transformation reaches education. Schools in underserved regions power laptops, projectors, and internet hubs without relying on fragile grids. Hospitals operate entire wings off battery walls. Rural clinics never again choose between lighting and refrigeration. Emergency medical drones recharge mid-mission. Battery-powered desalination plants turn salt water into clean drinking water for thousands. All made possible because a single innovation reached maturity. It's not a leap forward, it's a chain reaction. Every field touched by electricity gets touched by aluminum-ion. The economics shift dramatically. Consumer demand for faster, safer charging becomes the new market standard. Lithium-based products lose appeal. No one wants to wait an hour when 10 minutes will do. No one wants to pay more for less range and more risk. Companies that adapt win instantly. Those that don't face extinction. Retailers shift stock. Policymakers scramble to adjust regulations. Insurance companies lower premiums for vehicles that don't burn. Municipalities reconsider public fleet contracts. Aluminum batteries aren't a niche product, they are the rulebook now. Even in global politics, this new technology causes tremors. Nations with lithium monopolies begin to see their influence wane. Those rich in aluminum rise in diplomatic importance. The battle over battery resources becomes more open, more fair, and far less toxic. What once sparked conflict now encourages collaboration. Aluminum becomes a bridge rather than a barrier. This is energy democratized. This is mobility guaranteed. This is freedom delivered by chemistry. Tesla's decision to go aluminum is more than smart. It's seismic. Every move since their founding, every gigafactory, every solar tile, every charging station, now aligns with this masterstroke. Because this battery completes the picture. It makes every Tesla product stronger, safer, and more efficient. A Tesla home battery becomes a generational asset, not a temporary solution. A solar roof now has a partner that matches its lifetime. Tesla's robotaxi fleet, A cost-effective powerhouse requiring fewer maintenance stops and nearly no fuel cost. The ripple effects stretch for decades. Even cryptocurrency miners shift to aluminum-powered rigs for stability and cost efficiency. Data centers adopt these batteries to protect uptime while cutting diesel backup. The dream of a planet-wide, wireless, battery-supported grid inches closer. The long arc of innovation has bent toward this moment, and while Tesla may have pioneered it, the rest of the world must now follow. Because this shift is not optional. It's inevitable. It redefines how progress is measured, not just by what we build, but how it's powered. In classrooms, future generations will not be taught about lithium as a solution. They'll learn about it as a stepping stone, a necessary but flawed phase before the real solution emerged. They'll study 2025 not as another tech year, but as the year the battery era split in two, from scarcity to abundance, from hazard to safety, from temporary to permanent. This battery is not a feature. It is the foundation, and now we all stand on it. The question is no longer about if the shift will happen. The question is whether we move with it or get left behind, because the aluminum era has arrived, and lithium, for all its early glory, has reached its final chapter. Tesla just turned the page, and the future, charged, clean, and infinite, has already begun.